Thank you for joining me. Let's talk about what a reward really means in the training of large language models, and how it compares to the loss function used in pre-training. First, let's start with pre-training. When we train a language model from scratch, it's done with supervised learning on a giant text corpus. The model is shown billions of snippets of text. At each step, it sees a sequence of words or tokens, and it has to predict the next one. The correct answer is always known because it comes from real text. The difference between what the model predicts and what the text actually contains is measured by a loss function, usually cross-entropy loss. Cross-entropy is just a way of asking, how surprised was the model when the correct word appeared? If the model gave the correct word high probability, the loss is low. If the model gave it low probability, the loss is high. So in pre-training, the feedback is dense. Every single token produces a signal. The target is objective because the next word in the sequence is known, and the goal is clear. Maximize the likelihood of real text and become a strong general-purpose predictor of language. Now let's fast forward to the reinforcement learning stage, where rewards come into play. By this point, the model is fluent, but it doesn't necessarily act helpful, safe, or aligned with human preferences. That's where rewards enter. Instead of knowing the correct next word, we now rely on judgments about the whole output. A reward is a single number, a scalar score, that tells the system how good or bad that output was. Maybe a human gave it a thumbs up. Maybe an automated system said, yes, that code compiled. Maybe a reward model predicted that people would prefer answer A over answer B. Whatever the source, that reward signal is used to nudge the model. Reinforcement learning, often with an algorithm like PPO, adjusts the model so that higher reward outputs become more likely, and lower reward outputs become less likely. So in this reinforcement stage, the feedback is sparse. Instead of a signal at every token, you only get one score for an entire output. The target is subjective, because it reflects human preference or task requirements, and the goal is alignment, making the model behave in ways people actually want. Here's a quick analogy. Think of pre-training with loss functions like a student memorizing vocabulary from a textbook. Every answer is right or wrong, and the teacher gives instant feedback on each word. It's dense and objective. Now think of reward fine-tuning like that same student giving a public speech. There isn't a single right answer anymore. The feedback is the volume of applause from the audience. It's sparse, subjective, and it shapes how the student learns to present themselves. This is why both are necessary. Pre-training gives the foundation, knowledge and fluency. Reward optimization gives alignment and usefulness. Without pre-training, the model wouldn't know language. Without rewards, it wouldn't know how to behave in ways humans prefer. Finally, here's a timeline view that ties it all together. Stage 1 is pre-training with loss functions. Stage 2 is supervised fine-tuning on curated examples. And Stage 3 is reinforcement learning with rewards, aligning the model to human values and practical use cases. That's how loss and reward complement each other in the life cycle of training large language models. Thanks for watching. Please like, subscribe, and share.